Mike Robellard with, from Synchronous to Asynchronous Postgres with Tornado.
All right. All right, hello everybody. My name is Mike Robellard, and we're going to be talking about writing asynchronous code in Tornado, mainly talking about Postgres database stuff related to that. These slides are available online. There's a URL for that. And the code that I'm going to be talking about is also available on a public GitHub, which is also on there if anybody wants to see that. So a little bit about me. Right now, I am the director of technology at a startup, which basically means I'm one of the people that founded the startup, is what it really means. But we make a product called EHR Tutor that nursing instructors use for teaching them how to use, EHRs. Oh my God, I don't believe No, we don't teach nurses about object relationship mapping. That's what we're going to be talking about here. I can't believe I didn't catch that before, yes. No, teach them about electronic health records, not object relationship mapping. But we use object relationship mapping in the code, so that's all good. I am the former senior software architect at OnShift, and there's a bunch of people from OnShift here. So before that, I worked at American Greens. There's even American Greens people here. It's like it just follows me around. I can't leave my previous companies. Okay, so that's enough about me because it's not that interesting. Okay, so for this talk, I'm assuming that you at least know what asynchronous is. Hopefully you went to David's talk this morning because it was really good and taught you about asynchronous. If you didn't know what it was. I'm also assuming that you know what Tornado is and that you understand how to talk to a database on software. So this is meant to be kind of an advanced talk, and that there are some assumptions I'm making, so I won't be going into a lot of details about the basics of this stuff. But what we are going to go over is I am going to review a little bit of ORM stuff. I gave a talk 2 years ago about object relationship mapping, and we're going to briefly go over a little bit of that because it does play into the code that we're going to see a little bit later. And then what we're basically going to do is I've written 4 versions of the exact same code. It does the exact same thing, but it does it 4 different ways. First, it does it the old-fashioned synchronous way. And then I wrote the same code that uses a library called Momoko, which is the basic, uses straight Tornado asynchronous stuff to do asynchronous I/O. Then I wrote the same code using the async I/O library and using a library called Aiopg to do the same database stuff, exact same stuff, but using the new async I/O and 3.4. And then for the final one, I wrote the exact same code using Gevent. And all of these are running on Tornado for the web application. So we're going to talk, I'm going to kind of show you each one of those, the differences. If anybody has any, if anybody sees something that they're like, why would you do that? Just blurt it out, that's fine. And then at the end, I'm going to wrap things up a little bit. And that's basically what we're going to talk about. So object relationship mapping. If anybody was at my talk 2 years ago, I'm very opinionated about object relationship mapping code. Especially when it comes to things like Django's ORM and SQL Object and some of the other ones. I really don't like them. And SQL Alchemy is good. It's really super complex. But the reason a lot of that complexity comes up is because SQL Alchemy is built to talk to every single database in the world. And it also provides stuff for handling the DDL, handling, building queries, doing pooling, and it does all kinds of stuff like that. That's all great, and a lot of people like that. And if you like that, there's nothing wrong with that, especially if you're trying to build something quickly. But when you start to try and build advanced stuff, and you're working on an ORM, the ORM tends to really start to get in your way. And it doesn't need to, because all an ORM really is about mapping database tables to objects and mapping the relationships between them. That's all an ORM is supposed to be, and all the other stuff is really fluff on top of that. So you can do this a lot simpler than using these big libraries. And the code that we're going to be looking at today, which makes this a lot easier to, when we're talking about the asynchronous stuff, because we don't have all that overhead of using an ORM, is going to make it a lot easier to see the asynchronous part of it. So real quickly, a little bit more about that. So Psychopg2, the library that we all use when we're talking to Postgres, provides this wonderful ability to have adapters, which will basically take a type from coming out of Postgres and turn it into a class for you. And the records coming out of rows in a table are a type that can be adapted to a class. So conveniently, you can just go and say, take this row and spit it out, and it'll, as a single element, and it'll turn it into a class for you. And that is the main thing that we're using to accomplish the object mapping. And then, which we're not actually going to use this today, so this isn't really all that important, other than to know that I've written it and it works. But if you're doing relationship mapping, which this is such a simple application that we're going to be using to show these examples, there's no relationships in it, it's one table. But in order to do that, we basically have a recursive function that goes through a bunch of row results and says, hey, let's put these together based on how the relationship should map, and that's how we do that's how I do the relationship mapping. And I use this method in production code, and it seems to be working fine. So that's that. That's not really what we're here to talk about. We're here to talk about Tornado and asynchronous stuff. But before we do that, we have to look at how you would do this in a synchronous world. So we go over here, and you'll see we've got the world's simplest web application ever written. It's got a single link on here that says new game. And when we click on it, it says, give me a name for this game. So we're going to call this Ohio. And we're going to hit submit. It goes back to the original one, and now PyOhio is in there in the database. And it came from the database. So, like I said, it is the simplest thing you can possibly implement to actually show this. So let's take a look at the code. Everybody can read the code, right? In the back? Okay. All right, so the important things here. We do a bunch of imports. Imports are only important as long as you make sure you have them all. But what's really important here is our model class. So this is our model class. And it uses my very simple ORM, and I can show that to you guys in a little bit, but it's like really simple. So all this is saying is here are the fields that exist. This is the query that you would run if you want to insert data. Here's the query that you want to run if you want to update the database, update the table. And then the actual interesting things are if you want to do get the data out or get all the data out, we actually provide a method for that. And unlike if you're using an ORM, you'll see that we are actually writing SQL, which is good. If you need to write really complex SQL, you can just stick really complex SQL in it, and returns it. But this is synchronous code. It is straight up, here we are getting a Psychopg cursor. It's the normal getting a Psychopg cursor. We're executing, we're fetching all. This is the build relationship that actually doesn't matter in this case. And we're returning the results. Same thing in the get all. Let me real quick show you the ORM side of it. So this is the ORM. Most of this stuff is not relevant for what we're talking about today. This is the relevant part. So my init just does some basic setup stuff to handle the fact that you can pass in some keyword arguments and that they map them into the into __ dict. This handles some of the relationship stuff. This just returns a dictionary out so that you can get nice, simple JSON encoding. And then, obviously, this is a fairly important one if you want to use the getAttr for accessing your things. But the stuff that we're really interested in here is the update, which, as you can see, all it's going to do is call that update. All it does is calls the update query that we set in the class below. And then save. Says, hey, if we already have an ID, call update. Otherwise, insert it. So this is some really simple stuff. And that's literally that's the entirety of the ORM. It's, you know, the rest of this is just some stuff for the relationship building part of it that we're not using, so we won't talk about it right now. So anyways, this is Tornado. So, oh wait, one more important thing here. So this game composite right here, this is the adapter. This is the adapter for Aiopg. So the existence of this is what allows us to say, hey, we've got a thing that came out of Aiopg. We're going to turn it into a dictionary. We're going to pass that dictionary into the constructor for our game class, and now we have a game object coming out. So you have to provide one of these for every single model class that you create. You could probably come up with some cool way to make that actually be part of the game class and stuff. I just haven't bothered because this is easy enough, and I like to keep things simple. Now we're into our controller stuff. I wrote it all in a single file because, well, it's an example and it's easier if everybody can just see it all in one thing. So it's transactional. So when we finish the request, we want to make sure we commit to the database. Otherwise, nothing's actually going to happen to the database. If there's an exception, we want to roll back. And then here is our actual things we're going to do. So here's our get, which calls the game get all from above, and then renders the HTML that you saw the output from earlier. Here is the here's the one for the edit. You know, same thing. If no ID is passed in, then we're just assuming that we need to create an empty one to use. Otherwise, we go and get it out of the database. When we post, we do the same thing. If the ID is passed in, we get it out of the database and modify it. Otherwise, we go create a new one and modify it. We call save. Save, as you saw in the earlier code, automatically knows whether or not it is a new one or an old one based on whether or not the ID exists. And then we redirect back to the main HTML page once we're done. So this is literally the entire app. It's very simple for this example. For our purpose, what is important is you can see we're just doing a regular this is Aiopg. We're starting a Tornado IO loop, the regular Tornado IO loop here, and we just run it, and it runs the normal way that Tornado would run if you're doing something synchronous. It's actually very boring stuff, which is good because we're going to make it not boring here now. So now, go back to the top. All right. So from what we saw, it is, you know, normal transactional code. The one thing is that we're going to lose some of the advantages of using Tornado because that was synchronous stuff. So what's going to happen is you're going to make a request, and you can have lots of requests come in, but you still have the synchronous blocking on the database access code, which would be nice to kind of get rid of that. And that's what we're going to talk about doing next. So one way to do that is to use a library called Momoko. Momoko is a library written specifically for Tornado to do asynchronous I/O with Postgres. And I'm going to show you guys the code to do the exact same thing we just did synchronously, but this time we're going to use Momoko to do it. So the first thing is we had to change, in order to do this, the first thing we have to do is we have to change our ORM a little bit. So I've subclassed the previous one that we had, the same ORM that we had before, but the difference here is now our update and our save methods are coroutines. And what that allows us to do is by doing that, now we are going to, instead of just calling our execute method, now we have to yield it. And the nice thing about Momoko is we can just say, here's the connection. We're going to, rather than normally, before we got the cursor, now we're actually just saying yield off the database, execute this, and we're passing the cursor factor here as a parameter instead of getting the cursor and doing the stuff the first way. It's basically, Momoko has a nice way of kind of shortcutting those two things. Otherwise, you have to get the cursor, yield that, and then yield the results. This is just a way to shortcut that process of having to do two things. And that is the change that we have to make here. There aren't many changes that we had to make at this level to do that. You'll see everything else is the same. The queries have not changed from the original version. What has changed, though, is our get and our get all. Just like our save and update into the ORM levels, the get and the get all have also changed in the exact same way with the yields here and here. Now notice in this one, we only have to put a yield here because this yield is saying, hey, this is a future, and then when you call fetch all on this future inside Momoko, it says, oh, okay, go and handle that and return an actual value as the results. And so the rest of that is handled under the hood. So you only have to do the yield in one place here. The other change is we had to make these all coroutines on our controllers. We needed to yield the results of our calls to the model now instead of making a straight call to the model. Now they have to be yielded instead. And then down here, we have to do a little bit of magic to get the database set up properly. We have to create a pool because since we're doing asynchronous stuff, we're going to potentially be using more than one connection at a time to the database. So now we have a pool of connections instead of a single connection. This is just some stuff that you have to do to tell Momoko to load the, you have to actually create the pool and stuff. And then once you've done that, this is a little hack I had to do in order to get the composites to register. You'd have to do some work in Momoko to actually allow it to call the register composite under the hood because it's assuming a synchronous connection here and we have an asynchronous connection. So I just make a second connection, and once Aiopg knows what's happening here is that in order to register the composite, it has to query the database and get the OID out of Postgres for the game table in order to know how to map those properly. So in order to do that, it needs a database connection. That's the only thing it's actually using us for. The rest of that, that's storing it in the globals of the Aiopg2 library. So you can use Aiopg2 with multiple different connections and only have to register the composite once when you do this global equals true. So that's kind of a hack I had to do to get that to work. You could fix that hack, I just didn't have time. So you would have to go and work in the Momoko library to actually kind of do register composite differently. So I've actually talked to the author and we've talked about how to do it. We just haven't written the code. Well, no. What you would do is you would write a Momoko version of register composite that would go and do it. Is how you'd end up fixing that. So there isn't, as you can see, there's not a lot of differences here. One thing that you may have noticed was that all the transactional stuff was gone. And that's because by default, when you go into asynchronous stuff, the default is you're now in auto commit instead of transactional. That doesn't mean you can't do transactional. You can do transactions. You just have to manually do them yourself, which is kind of a pain in the butt. But it can be done. I didn't bother to do it for this one because it would have made the code messier and I was running out of time to do it. But it is hard. It makes it a lot harder to do. The other thing that you probably saw is you have to yield and use gen coroutine pretty much everywhere. Any place that you want to make something asynchronous, you have to do the yield and the gen coroutine. And the problem is once you've done that, you cannot really unasynchronize asynchronous things. So once you've made it a asynchronous thing, you've got to use it asynchronously. It won't work the old synchronous way. So you can't mix and match very well. You have to go one way or the other with your stuff. The other thing that is kind of sucky about this is let's say that you want to use your models that you've written and you want to use them in a offline module as well as in your web application, well, now if you're using Momoko, you've got to run a Tornado I/O loop in your non-web code, and that's kind of not the world's best solution. So there is a solution to that problem, and that's one we're going to talk about next, which is we could use async I/O and Aiopg, and so instead of relying on Momoko and relying on Tornado-specific stuff, now we can rely on stuff straight out of the standard library from Python 3.4. Aiopg is a library for doing asynchronous I/O and Postgres. So, no, it uses CyclePG as well. And you'll see that my IDE is not set up for 3.4, and it thinks there's errors all over the place when there's yield from. So once again, we have, oh, hang on, let's look at the ORM changes first. Okay, so once again, I've taken the regular, my regular ORM that I created, made a subclass of it so I could override, update, and save again. This time, you'll notice that instead of doing a gen.coroutine out of Tornado, I'm now using the standard library async I/O coroutine. So there is nothing in here, there's no longer Tornado specified anywhere in here. So you can use this outside of Tornado, which is a good thing. The other thing that is different from the Momoko one, there's two other differences here. You use yield from everywhere instead of yield. There are some differences between what yield does and what yield from does. And they are like super technical detail-y things that half the time I even forget what they are, but you need to use yield from here. Yield will not work. If you try to use yield, you're going to get all kinds of nasty exceptions. The other thing is I have, if you'll recall, there was only one yield in the other one. Here there's two yields, and that's simply because first you have to get the cursor, and then you call execute on the cursor, just like you would in normal CyclePG. So this one actually looks, in that way, it looks more like the original code, with the exception of yield froms instead of just calling the functions. And then the same thing down here, except also when you get the results, we have to yield from the results as well here. So the results are still a future, and it's no longer a future until we get down here where we're actually using the results. So when you're doing, so in asynchronous stuff, when you're doing anything asynchronous, all those yields are returning, those yields are yielding. You know, a yield is a generator, means we're using generators here. What they're returning each time you call the yield is they're returning what's called a future object. And the future object basically keeps gets passed around and stuff, and that's what actually allows the asynchronous part to happen. But when you get to a place where you're using the value as opposed to just kind of passing it around, the first time you go to use it, it goes and says, hey, evaluate it if the asynchronous call has not completed yet, right? Because it's a call to the database. The call to the database may not have been completed yet. Then we're going to sit here and wait and give up execution to some other asynchronous piece of code. This is where the asynchronous part comes in. So your code will run straight through. It'll go and tell it to run the database until it gets to a place where you're using the results from your yields in something useful. And then it's going to sit there and wait until the results actually come back on the database. But it won't block. What it'll do is it'll wait, and then it'll go and wait for the results from another. It'll go and look at the other things that you have asynchronously and try them as well. So that's where the important thing happens, is when you actually go to use the results. And that's what makes these things, that's what makes all the asynchronous packages work that we've talked about. Both Momoko and Aiopg work the exact same way in that regard. All right, where did there it is. So, once again, as you can, there's very few changes we have to make, except from, here's our yield froms again. The exact same thing that we saw just a minute ago. You have to yield from the cursor, yield from the execute, yield from on your fetch all. These are literally, Aiopg was very They tried to make it look as much like regular Psycho-PG as possible. So you call the cursor function to get a cursor. You call execute a query. You call fetch all to get the results, and then you just yield from all of them. And we're doing the same thing on the get all. Then the only other thing, nothing else has changed here from the previous one, except now we're doing yield froms instead of yields. Now, one thing you'll notice, these are still gen coroutines because we're inside of Tornado, and Tornado is expecting the Tornado stuff. And Tornado has some adapting that it does automatically under the hood that says, hey, this is an async IO future, but since we're kind of have the two mixed, you're allowed to take the async IO future and return it into a Tornado coroutine, and it works. So so here's where the other big change is. In order to get the setup to work, in order to actually get the connection to work, the connection is also asynchronous. The connection setup stuff is also asynchronous. So what I had to do to make that is make a coroutine that does the database setup. It does a yield from the pool in order to create the database pool object, which is basically, it's a connection object. It works, as you can see, I used it as a substitution for the connection object in Psycho-PG. It is actually a pool under the hood. And in order to do that, so we have to call this install, which what this is saying is take the async IO loop and install it on the Tornado loop so that the two loops are basically merged together. Now we can get the event loop. We can run until complete this DB setup on that event loop, which basically goes and says, okay, now we can go run this thing to get the pool all set up. Then we're back to everything normal, except for we're now running loop run forever instead of the normal start app that we would do for Tornado. You do have a different thing you're starting. And that is what we're going to do to make it work on async IO. All right. So one thing, the transactional is even a little bit harder in async IO. Momoko has a couple of methods that kind of make the transactional harder. In Aiopg, they say run a call select, to basically do a begin transaction and an end transaction as an actual query, and that's how you would do transactional. There. So transactional is a lot harder here. Once again,
so you're saying if you have one kind of entry point, you want to do like 2 inserts and an update, it's tricky to say all or nothing.
Exactly. And it makes sense if you think about it, because you can't actually do that way because you have two different if you do that and if you just blindly try to do that, the asynchronous library by default is going to go and try and get two different connections, because the pool, every time you call the pool, it's saying, get me a free connection. Yeah. And transactions run inside of a connection. So if you have two connections, you're going to have two different, you're going to be running them in two different places. So that's going to create problems for you. There are, like I said, there are some ways around it. For instance, the Momoko library has a function call, and basically what it does is it says, take all your calls that are going into this transaction, put them into an array, and it basically wraps them around a begin and end transaction and dumps the whole thing to the database at once, and then waits for the results from each of the queries. Is how Momoko handles it. The problem is that won't work particularly well if you want to have transactional stuff happening in 3 or 4 different functions, and how are those functions going to know that they're communicating with each other? So that creates, so the transactional stuff, when you get into asynchronous stuff, it's hard. Once again, you have to do the yield and use the async IO coroutines, just like we saw before. You have to do the little bit of event loop switching. But the nice thing about that is now, because your model code is written with async IO, you can run it in any place that you're running an async IO event loop. So you can run your async IO event loop in your code that is going offline and doing offline processing stuff and still using your model code without having a dependency on Tornado. The other thing that is nice is if you are a SQL Alchemy user, Aiopg, the library that does this, provides some monkey patching to allow it to work with SQL Alchemy. I have not tried this, but I wanted to bring it up because a lot of people like SQL Alchemy. There's nothing wrong with it. I have no issues with SQL Alchemy. And you can use it with this. The other thing is, and I think I mentioned this when we were looking at the code, the yield from is really important. When I started I spent 2 hours realizing that I had yields where I needed yield froms, and it made it really hard to figure that out. So yeah, you need to use yield from when you're using async IO, and you use regular yield when you're using Momoko. That is really important. Okay, so now the last one that I wanted to show you guys. So the last one I'm going to show you is using Gevent. So if nobody knew, you can use Gevent with Tornado and get asynchronous stuff out of it. One thing you're going to notice is there's no special ORM code required for this. And so I have an async IO and a Momoko and the regular synchronous stuff, but I don't need one for Gevent. And that is because the way Gevent is written. Gevent, for those of you that don't know, uses the whole green thread, greenlit concept of things. So you're basically creating not real threads, but little mini threads that are doing the work. And the nice thing about that is Gevent basically does a little bit of monkey patching. You have to do this at the very top in order of your application in order to actually get it to work right. But basically what that does is that goes and says, hey, anytime I'm going to go and do something that would be normally, that we would want to have asynchronous stuff, go ahead and release the, it's not a guild, but it's basically release the lock and do the normal greenlit Gevent kind of pseudo thread stuff, that it works similar to threads. Sorry, I'm not coming up with good words, but I know there's better words to describe that. But the thing is you're going to see, the nice thing about this is the code is the exact same code from the original version. Get all, the get, everything is exactly the same. We can do transactions, normally, commit, rollback, all that stuff. The places where we have a change, and the only changes we have is here. We are in our get. We're using the regular Tornado asynchronous. It's not a coroutine, but it is an asynchronous web request. And then what we're going to do is when we get the web request, we're going to say, all right, go spawn a greenlit to do this work. And we go off and we do the work, and we're done. And we can do the same thing here, and the same thing here. And the work is done in these very simple functions that are basically doing the work. So it is, in my mind, this is a this seems like a much easier way to understand things. It's not true asynchronous in the way that the other two methods are, but it's a lot cleaner to read, I think. So the disadvantage here, of course, is that inside of this async task, everything is happening synchronously. So if you went, unlike our other ones, if we wanted to do multiple calls to the database, each call to the database is going to be synchronous inside this asynchronous task. Whereas if we were using the synchronous code that I showed you earlier, you could do every single database call as a separate asynchronous query, and then you could have one wait for the other one, and and have the asynchronously down to a lower level.
So what would you say is asynchronous with this? It doesn't seem like anything is asynchronous.
So the thing that's asynchronous with this is what will happen though now is when this goes off to the database, it's going to give up it's going to basically give up its lock on the Python interpreter and let other stuff run it.
So instead of having 10 worker processors, you still only have one worker processing the request.
So it's a slightly different model. To be honest, I will tell you right now, I didn't like performance test any of these, so I have no idea which things work the best and what the performance trade-off is of doing it this way as opposed to doing it the traditional way. But I was basically wanting to present you guys with the options of how you can do it. The other thing is you would probably want to actually put this in some sort of pool if you were doing this for real, because otherwise you're still actually only running off of a single database cursor and stuff like that. I mean, a single database connection. So this is not done properly for using the Gevent the right way. But the point I was trying to make with the Gevent example is it's a different way of doing it than the other ones I showed you, and it's simpler in a lot of regards because all you have to do is do this as opposed to populate, put coroutines everywhere, and it's a very big paradigm shift to do the normal asynchronous stuff as opposed to the Gevent model of doing things. And basically all the things I just said are repeated here, I think. You only have to modify your controllers. The models were exactly the same as you saw. Which is nice. The nice thing about this is if you want to mix synchronous and asynchronous code, you can do that without a problem because you haven't modified your models. You only have to do your controllers to make the asynchronous stuff work. You don't have to have the coroutines everywhere. And as I mentioned, you can't have easily lots of asynchronous things going on inside of a thing unless you spawn. You'd have to spawn separate greenlets for everything you want to do asynchronously in order to get that to work. So if you, otherwise, inside of the actual greenlet, everything is synchronous. So yeah, the other thing is since we're not using the coroutines, you can run the model code without the requirement of having an I/O loop at all. I think I already mentioned that in a way. You can use transactions still because everything inside that asynchronous task, once again, is synchronous, so you can use transactions just like you normally would because it's all synchronous inside of there. And the other thing is you can use SQL Alchemy with this. Oops. Oh. Sorry about that. Okay, so that blog link at the bottom is, I will shamelessly tell you that I figured out how to do the Gevent stuff by reading that guy's blog and copying and pasting it into my code and seeing if it worked, and it worked. So that person's blog is actually the go-to thing for figuring out how this works. So I figured I should plug the person that actually figured out how to do this for me. I did not figure this out on my own. Okay, so kind of in summary here, coroutines are hard. They're easy to mess up. It's a paradigm shift. You have to really wrap your head around it. It's not easy to do. But the advantage is you get the asynchronous stuff out of it. Now, mind you, I've only been talking about asynchronous from the point of your web request talking to the database. Earlier today, if you went to David's talk, he showed some asynchronous stuff from the front-end side of things where he was doing WebSocket and asynchronous things there. And that is a totally different, it's the same kinds of things, but it is a slightly different thing. And once you put all those things together and you start to build a really complex app, you get a lot of things. But what we've really only talked about here is the back-end side of doing asynchronous stuff, and not the front-end side. And the methods that we talked about here, even though we're specifically using Aiopg, if you are switching that out with Redis or, God forbid, Mongo or whatever other thing, whatever other thing that you like to use, the concepts are basically the same. Yes, I'm opinionated. I admit it. There are three choices here that I showed you, and each one of them is good in their own way. The Momoko stuff works on Python 2.7 as well as Python 3.4. So if you're stuck in Python 2.7 land, you can use that. The async IO gives you the ability to use stuff without having dependencies on Tornado. You know, and then there's the Gevent model, which makes things a lot easier. So there's a lot of different ways you can accomplish the same thing. And I wouldn't say that there's a right or a wrong way. I have not used this in production yet. I've only been using this to build some tests and samples and working on some projects, some side projects with it. So I haven't really decided which one I even like, because I see advantages and disadvantages to all of them. You know, the async IO method, and Gevent, you can both get to work with other ORMs, particularly SQL Alchemy, which is a good thing. You know, I am not a huge ORM person, so that wasn't a big thing for me, but a lot of people are, and there's nothing wrong with that, with caveats. I'd be happy to discuss those. And the other thing is that, you know, you don't have to necessarily be tied to Tornado here. You can use the async IO stuff with whatever your favorite other framework is, and Gevent will also work outside of Tornado as well. And so anybody has any questions, I'd be happy to take questions. There's lots of contact information for me. Feel free to contact me in whatever way you see fit and like the most. So any questions? Matt? I can call him by name, I know.
So going to auto commit just seems like a huge step backwards, and I can't wrap my mind around the implications for that, but have you thought about that at all?
So in the one sample, one of the things I was doing when I was actually trying to build something for real with a real project with this, what I ended up doing is I created two connections. One was a synchronous connect, and this is before, this was a couple, when I first started playing with this, so I haven't tried using some of the transactional things that you can do. But the way I first decided to address that problem was I created two connections. One was a synchronous connection, and one was an asynchronous connection. And when I wanted to read from the database, I used the asynchronous connection, and when I was doing a post, I used the synchronous connection on the post, and so everything was transactional inside there. Any more questions? About anything? Life, universe, whatever?
What's sub SSN?
And four rows back there.
The yield from fetch all in Aiopg.
Mm-hmm.
You had to yield from the cursor creation, the execute, and the fetch all.
Yes.
But I don't quite understand why. I figured once you got to the point of fetching all, I thought the data was on your client machine. In the PsychoPG world, in just simple PsychoPG too. So I don't understand why the fetch all would be asynchronous.
So in Aiopg, they have decided, because if you saw in Momoko, that was the case. In the example code in Momoko, that was exactly what you said. It was when you did the fetch all, it actually went and got it. In the Aiopg case, they're actually waiting until you use the results fetch. So the fetch all is returning, once again, another future that's being, so it's delaying it until you're actually using the code inside of there. So just delaying it. They've chosen to delay it to the absolute last possible minute. And you can, the one thing in async IO that you can do with that fetch all normally in PsychoPG returns a list. In the case of Aiopg, it is actually returned, because it's a future and it's a generator, you can actually act on it as a generator. So you can take that, you put that fetch all in a for loop, and it's going to be treating it as a generator, not as an iterator. So it's not, you're not iterating on a list, you're iterating on generated things there. No, it's still using it's just like fetch all, it's doing that, but it's doing it, because even if you run fetch all doesn't actually go get everything out of the thing. It goes and gets them in batches of whatever the batch size is set to in PsychoPG, I think, as I recall. Any other questions? Okay, thank you very much.